Today we're going to take a look at lesson 6 titled Increasing and Decreasing. And if you look at our learning goals today, we're going to be talking about tape diagrams as a way to represent what we've been doing. This is not anything new. We were using tape diagrams a couple lessons ago when we talked about fractions and decimals and representing those different situations, but we'll do those again today when we talk about percent increase or decrease. We're also going to use a starting amount and the percent increase or decrease to find the new amount. So today is all about working with percentages. So we've built up to this. We started with tape diagrams, equations, and situations with fractions. Then we did decimals, and now we're just going to switch it over to percentages. For our first question, here's where we're going to take a look at those tape diagrams again to kind of review. And there's different versions of what a tape diagram looks like. Since I'm drawing it, I want to do kind of a quick version and what that's going to look like. So the first example says a cereal box says that it now contains 20% more. Originally, it came with 18.5 ounces of cereal. How much cereal does the box come with now? So for a tape diagram, which is a lot like a double number line, if we are comparing two things, and these would have been like bars, tapes on the other example, I'm just going to draw lines for today. But what we're doing is we're representing the starting amount, which would be 0 ounces and 0%, since today we're talking about percentages. And then on the other end, we'd be talking about what it used to come with, 18.5 ounces. And that would, of course, be 100%, all of the cereal box. So what we used to say was this was the one thing, the whole amount, the one amount, and then we would either add to that one or take away from that one, depending on the situation. Now we're just talking about percentages. So 100% represents the whole thing, all of it. And remember, when we convert between percentages and whole numbers, 100% does equal 1 because it's 100 per 100. 100 over 100 is equal to 1. So let's now look at what we were asked. So it says 20% more. So clearly we're going to be extending past this. 20% more would be 120%. And we just need to find how many ounces that is. So we need to know what 20% of the cereal box was. So we could divide this up into 20% sections. So we would have 5 of those here in the cereal box, 20, 40, 60, 80, 100. So this being 20%, we would need to find out how many ounces that is. That's going to be very key in solving this problem. Now, we don't have to use a tape diagram to do this. This is just demonstrating what we're doing. We could take, since there are 5 equal sections here in the whole cereal box, the 100% of the cereal box, we could take the size of the box and divide it by 5 to figure out what 120% section is equivalent to. Or, and this is what we're going to use more often, is we're going to use multiplication. To find 20% of something, to find any percent of something, we multiply. We take 20% times whatever we're trying to find 20% of. All right, and again, that's the multiplication symbol there. But this is not 20 times 18.5, or we're going to get some huge number. Instead, what we're multiplying by is the decimal equivalent to this. Remember, this is 20 per 100, 20 out of 100, and that would actually be equivalent to 0.2, 2/10. So that's what we're doing. If you use a calculator, you're doing 2/10 times 18.5, 0.2 times 18.5. And that equals 3.7. So we just found that 20% of the cereal box is equivalent to 3.7 ounces. Now, because the cereal box is getting larger, it's increasing, then what we're going to do is we're going to increase this amount by 20%. So we're going to take the size of the old box and add on the extra 3.7 ounces. So we're going to take the 3.7 ounces, add on the 18.5 ounces, and that gives us a total of 22.2 ounces. OZ is just the abbreviation for ounces. All right. Now, we could also find that in another way, and I just want you to be aware of it. We're going to talk about this a lot. Since our cereal box is now 120% of the size of the original box, we could have taken the original size of the box here and multiplied it by 120%, which would be 1.2. That would also get us the same answer. And we'll talk more about that a little bit later. For the next one, it says the price of a shirt is $18.50, but you have a coupon that lowers the price by 20%. What is the price of the shirt after the coupon? So here, going back to our keywords, we're lowering the price by 20%. We're going to be taking that away or subtracting it. And if we use the same diagram, because if you notice, it says the price of a shirt is $18.50. That's comparable to what we were just talking about for the cereal box size. But now we're lowering the price, so we don't need to extend past 100%. We actually need to decrease, and each of these marks was 20%. So now what we're doing is we're removing 20% of that, and what we're really going to be paying for the shirt is for 80%, and we need to find that cost. So if the whole price is $18.50 and we take away 20% of that, or $3.70, we could just take our shirt's cost and remove the 20%. Remember that 0.7 is actually 70 cents, not 7 cents. And what's going to be left is the same amount, but this is a, oops, sorry, no, it's not. That was the example where we added 20%. If we take away 20%, our answer is $14.80. And that would be the reducing the price by 20%. Or we could have taken 80%, 0.8 times the cost of the shirt to find that. Let's look at the next example. So more with tape diagrams. We're going to match situations to the diagram. And you see our two diagrams down here look very similar. The top bar is labeled for last year, and then we have this year. Now let's look closely at the differences. So last year is always identified as 100%. That's our whole amount that we're comparing to in both examples. This year, we're extending past what it was last year. Here's our division. Here's that connection point there. We're extending past it by 25% this year. And if we look at this diagram, it looks like we've lost 25%. We've decreased this year to this point. Now that would leave, if we remove 25% or we go back 25%, we're left with 75%, because combined, we have our total of 100%. If we look back at diagram A, if we've increased by 25%, then really what we're looking at as a total for this year is 125%. So let's compare. Comparing this last year's strawberry harvest, this year's strawberry harvest is a 25% increase. That was definitely represented here with A, with an increase compared to last year. The next one says this year's blueberry harvest is 75% of last year's harvest. We've gone down, we've decreased, so we're referring to diagram B. Compared with last year, this year's peach harvest decreased 25%. That's still diagram B. And then this year's plum harvest is 125% of last year's plum harvest. That's an increase. So just a little more practice with these diagrams. Just remember that we're looking at an increase here and a decrease here in how it's shown. For the next one, it says the number of fish in a lake decreased by 25% between last year and this year. Last year, there were 60 fish in the lake. What is the population this year? Now let's look back. It says consider drawing a diagram if you're stuck. But since we're talking about a decrease of 25%, one of our diagrams from the last problem would fit that. That's going to be right here, diagram B. So last year was 100%. Remember it said that was 60 fish last year. Then it decreased 25%, so only 75% of those fish are now here. Now this actually divides up very nicely, and we could do this without using our calculators. So let's give that a quick try. So if we have last year 60 fish, if we want to find what 25% is, that decrease, we need to calculate how many fish that is, 25% of 60. So 25% is equivalent to 1/4. That means we're going to divide this into 4 equal parts. And 60 divided into 4 equal parts is 15 for each of those parts. Now, since the population decreased by 25%, the remaining amount is the fish for this year. 3 of these groups, 3 of these 15s. So looking back at this problem, we're going to have 45 fish this year. Now, without a diagram, we could have done that one of two ways. We could have taken all of the fish, being, let me see, let me use some colors here, being all the fish, we could have multiplied that by 25%, which is 25 hundredths, 25 out of 100. When we do that, we would get 15. Now remember, 15 is the number of fish that it has decreased since last year. So we need to go back to our original amount of fish and remove those 15 to get what's there currently. Now let me use a different color to show you another way. We could have done that in one step. If 25% of the fish have gone away, 75% of the fish remain. In one step, we can take the 60 fish times what remains to get the same answer of 45. And hopefully you see that. You can definitely see it here in the diagram, where if we subtract, we find 25% and subtract it, we get our answer, or we just find the 75%. Let's continue. On the back of your paper, we're doing an activity, agree or disagree, and this is kind of an interesting idea. You got to agree or disagree with the statement. So employee A gets a pay raise of 50%. Employee B gets a pay raise of 45%. So employee A gets the bigger pay raise. Now, think about that. We're talking about percentages. We're talking about parts of a whole amount. So, in a sense, we can all agree that 50% is a larger percentage than 45%. Here's the tricky part though. It depends on what amount we're looking at. So, if an employee was only making, let's say, $1 an hour, a 50% increase is only going to be 50 more cents per hour. But if employee B was making more than that, let's say $2 an hour, then 45% of that is actually a larger amount. It's a smaller percentage, a smaller portion of a bigger starting amount. So we can say we agree with it if the employees make the same. Agree with same pay. But we would have to disagree if they made different amounts, if they had different salaries. So let's look at the next one. Shirts are on sale for 20% off. You buy 2 of them. As you pay, the cashier says 20% off of each shirt means 40% off the total price. Well, for a question like that, we would need to disagree. The cashier combined the percentages, and it makes sense that 20% combined with 20% would be 40%. They're buying 2 shirts, but it's actually not true. If we had a shirt that cost $10, 20% of that would be $2. Let's see, let me do that a little differently. $2 is 20%. So this shirt is going to have 20% taken off. The shirt is actually going to cost $8. And that happens twice because there's 2 shirts. But if the cashier takes 40% off the total price, let's see, let's write real quick. So that's for 2 shirts, so it's going to cost $16 for that. But if we look at the total for 2 shirts, that's $20 for the original price. And if we take 40% off of that, we're actually taking off $8. So you would only pay for 2 shirts, you would only pay $12. You can't combine percentages. What the cashier should have done is rung up both shirts and still taken 20% off, because that 20% off is going to adjust to whatever the total amount is. So this cannot be true. We got to disagree with that. Now we're lastly going to look at one example from the practice, and that's our next question here. It says, last week I had 22 problems to pass the iReady assignment. Thank goodness this week it is 7% less. How many problems do I have to complete this week? So in the workspace, this is where you're going to show how you're calculating that percentage. And it's kind of limited for drawing a tape diagram. You can still do that if it helps, but let's try to kind of transition into just calculating now. So we need to find the percentage of an amount. We can use the 2 numbers here in the problem. We could take 22, the number of problems, times 7%. And remember, 7% is 7 per 100, and that's 0.07, 7/100ths. We can do that, but that's only going to tell us the decrease of questions. That means that we don't have to do, and this doesn't logically make sense here because we're going to have a decimal. It means we don't have to do 1.54 questions. But then what we're going to have to do is the next step, which is removing it from the total number of questions so that we can get our answer. That's okay to do. Or we think of that tape diagram and we remember we're losing 7% of the questions, which means how much of the whole iReady assignment is left. We started with the whole iReady assignment being 100%. If we take 7% of that away, that's going to leave 93%. What I'm doing is taking the whole assignment and we're removing the 7% because it's 7% less, and that leaves 93% of the assignment left to do. So in one step, we could take the 22 problems times 93%, 0.93, and in one step now we have our answer, 20 and 46/100 questions. All right, I hope this starts to make sense. This practice is going to be very good for you to try this. If one of these steps makes sense, whether it's going directly in one step with what remains, or whether it's removing or adding a percentage to it, pick the one that makes sense. Now remember, if a question tells you that something is increasing by a percentage or there's a certain percent more, then you do not subtract here, you would add that percentage. And the same would work here as well. If we had to do 7% more questions, we would be adding 7% to the 100, and this would not be 93%, it would be 107%, more than the whole amount. All right, I hope that helps. Please continue to practice this skill and jump on Zoom with any questions that you have. Have a great day.